Hello friends, welcome to Programming Concepts. My name is Amit and this is part 9 of our What's New in .NET 7 and C# 11 series. In this video, we will be comparing the performance differences between .NET 7 and .NET 6 for Linq aggregate methods. If you are interested in learning .NET Core from scratch, you can watch our dedicated playlist created specifically for that purpose. I will include the link in the video description. Let's jump into Visual Studio. I have already set up a .NET 7 console application for us. To compare the performances of .NET 6 and .NET 7, I have already configured the target frameworks to .NET 6.0, .NET 7.0. I have also installed the BenchmarkDotNET NuGet package. If you are unfamiliar with how to use BenchmarkDotNET, please refer to our previous video where I covered the simple steps. Now, I have created a C# class named BenchmarkLinq. It's marked as public and decorated with simple job. The memory diagnoser is set to false. Let's move to the program.cs class. I have already used benchmarkrunner.run with our BenchmarkLinq class. This line will execute the methods within the BenchmarkLinq class and provide performance statistics. Our setup is good to go. Now we need to create the method for which we want to compare performances. Alright, let's first talk about Linq. We all know that Linq is a productivity feature that practically every .NET developer uses. It simplifies writing complex queries, ultimately enhancing productivity through query comprehension syntax or direct use of methods in system.linq.enumerable. Right? However, productivity and expressiveness comes at a slight performance overhead. In critical and time-sensitive projects, I have seen developers opt for their own custom code over Linq to potentially make their application run faster, even if the performance difference is marginal. Microsoft recognized this challenge, and in .NET 7, they decided to improve Linq. They begin by targeting the enumerable.min and enumerable.max methods, which are frequently used with arrays, including large ones. They aimed to vectorize the processing. While I'm not delving into the vector feature here, it is clear that this process significantly speeds up performances for larger arrays. Moreover, even shorter arrays benefit due to direct access array, which reduces allocation and interface dispatch and enables optimizations like inlining. Let's cover an example provided by Microsoft to demonstrate the performance differences. Now, let's head back to Visual Studio. Let's define a property called length. So public int length getter and setter accessor. Let's decorate it with params. So params 4,1024. Next, we have to perform a global setup. So let's use the attribute global setup. Then public void setup such that underscore source is equal to enumerable.range 1, length .to array. Then let's create a minimum and maximum methods and decorate them with benchmark attributes. So benchmark public int min such that underscore source.min. Then benchmark public int max such that underscore source dot max. That's it. Remember to select release mode and run our application. The result might take some time, so I will pause the video and take you directly to the outcome. And the process is completed. You can see that .NET 6 is significantly slower than .NET 7. If we compare when length is 4, .NET 6 took 52 and 49 nanosecond for minimum and maximum method, whereas .NET 7 just took 6 and 5 nanosecond respectively. And it is around 10 times faster. And if we compare a bit larger length, which is 1024, .NET 6 took 7542 nanosecond, whereas .NET 7 minimum function just took 192. And similar result of max method as well, 6927 compared to 184, which is around maybe 40 times faster. Also, shift your focus to memory allocation. There was memory allocation of 32 bytes in case of .NET 6, whereas in .NET 7, it has 0 bytes allocated. This is an incredible performance boost by Linq. And also memory allocation of 0 bytes is insane. Now, let's see how it performs with float. I have placed the code in a notepad to expedite things. Let me copy and paste it into Visual Studio. Also, I will comment out our previous code. Here, we are creating a random array of floats, assigning it to the underscore floats variable, and then performing the sum, average, minimum, and maximum operations on the float array. It's a straightforward and extremely simple. Let's see how .NET 7 performs for floats. Run our application. Again, you can see that .NET 7 is significantly faster as compared to .NET 6. For some, the timing improved from 69.55 microsecond to 23.83 microseconds, making it 3 times faster. For average, the timing improved from 67.27 microseconds to 23.82, so it's around 2.5 times faster. For min, the timing improved from 81.06 to 14, making it 5.5 times improvement. For max, timing improved from 76.46 to 14.92, approximately 5 times faster. Furthermore, there is no memory allocated in .NET 7, while there is memory allocation of 32 bytes in .NET 6. Now, let's move on to our last example. Another commonly used operation is order by. With .NET 7, we have an option to use the order method instead of order by for simple types. For more details on order method, please refer to part 6 of this video series. The link is in the description. Let's see how the new order method performs. I will copy the code from the notepad and paste it here. I will also comment out our previous code. In this section, we create a random array of integers and benchmark both order by and new order method for .NET 7. We will remove the target framework .NET 6 from the project file and remove the simple job attribute from this class. Let's run our application. The statistics are generated. You can see order method is slightly faster than order by, 117 as compared to 127 microseconds. Also, memory reduced from 12.3 to 8.28 kilobytes. So it is advisable to use order instead of order by method for simple types. Simple, extremely simple. If you have already upgraded to .NET 7, start using these inbuilt methods of Linq for better performance and memory allocation. So that's it from this video. I hope you found the content helpful. If you have any questions related to the content of this video, feel free to ask them in the comments. Thank you for watching.